Hey, class. So, we're going to be learning more about earthquakes. And one of the earthquakes we did not talk about starts on actually page 26. I know I said page 28 in your planner. We're going to start on page 26 because in 1964, there was a great earthquake in Anchorage, Alaska. Now, we're going to go and take a look at Anchorage, Alaska, and I want you to see if you notice anything that might occur with a earthquake in Anchorage. So here is a map of Anchorage, Alaska. And right here in the center is Anchorage, actually just a little bit to the right. Now, as we zoom in on Anchorage, is there anything that you think might occur with an earthquake in Anchorage? Look right here. What do you notice? Go ahead and give me a thumbs up and tell me what you notice. Ooh, if you said it was by the water, you're right. It is right by the water, which means it could cause a what? Tsunami. And so as we look in the Great Earthquake in 1964, we're going to be talking about that. So go ahead and get your books open. Page 26. Where did I get 64 from? Page 26. Oh, 1964. It happened. Okay. Anyways, here is a song about earthquakes while you get your books. So, on the afternoon of Good Friday, March 27, 1964, Anchorage, Alaska was shaken apart, the most violent earthquake ever recorded in the United States. So, just a little bit higher from the 8.1 in San Francisco, we had an 8.4 on the Richter scale. It was at Government Hill Elementary School was split in two when the ground was beneath it dropped. Excuse me. Houses began sliding apart, giant cracks opened in the pavement, and the ground rolled into huge waves. In the first 3 days after the earthquake, 300 aftershocks shook the buildings that remained standing. There's a math problem right there. See if you can figure out 300 earthquakes. Let's see, 24, 48, divided by 72. And that's how many earthquakes happen in that time. 72 divided by 300. And go ahead and see if you can pause this video and go ahead and solve that now. Okay. So maybe you got how many of those that they got per hour? And those and that's are how many earthquakes happen there per hour? If you got about the answer of 4, you are correct. I think it's like 4.1 off the top of my head. Okay. And then here was a picture. I'll zoom out a little bit more so we can see the pictures. There's the school. There's one half of Hill Elementary and the other half. And you can see, look right where it's built on. Do you notice anything from something that we learned about? It's right there on that hill. And as if we learned, if you ever want to build a house, please don't build it on a hill or on top of a cliff or anything like that. Because if you get an earthquake or a tsunami or loose soil or anything, it's going to split. So make sure if you ever see someone building in your construction, anything, you're like, hey, you know what? This isn't a really good idea. I learned this in elementary class in 4th grade. Mr. Cox showed it to me. Don't do it. Because as we know, those aren't the best ways to go. And then right here, here's another one that Anchorage. Look at all these houses built on, again, a hill. And then you can see the water from the tsunami that's coming in, undoubtedly, and it's taking and destroying all these houses. Don't live on a hill. As beautiful as it might sound, you probably don't want to live on a big hill like that, because then you got the loose soil, and then you can even see it even took care of this Yukon boat right there. No good. All right, I'm going to zoom back in so we can see it a little better. The Good Friday earthquake brought another type of destruction along the coastline. The focus of the earthquake was deep beneath the waters of William Sound, and the Gulf of Alaska. The earthquake acted like a giant paddle, churning the waves. Churning as in like stirring up, churning it all together, mixing it all together. Tsunamis battered the land for hours. Why are we having so many tsunamis? Remember, there's 300 or at least 4 per hour that are happening. I know we say it's 30 seconds, but it's an average of 30 seconds in the world. So 4 per hour, just boom, 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 all the time. So the tsunamis are just like nonstop, because when that tsunami happens in the ocean, it takes a little bit to get there to build up and become a tsunami. That's a lot of tsunamis. An entire section of the waterfront at the port, and I'm right here for those who are following it. Let me highlight. Of Seward cracked off and slid into the ocean. Boats were overturned. That means turned over, like flipping around. Okay, so if one's boat side up, and now the main part of the boat is in the water. Buildings broke apart, and everything was left in a tangled mess. The tsunamis moved across the Pacific at speeds of hundreds of miles an hour, reaching as far as Hawaii and even Japan, 4,000 miles away. So again, if we pull up a world map, Okay, so here is part of the United States, and you're going all the way. It's really hard to tell that you're going all the way across and going to Japan. Japan is, where am I at? Oh, right here on the map. Japan right here. And coming all the way, that's 4,000 miles. So it's got to go all the way around the globe, around the other side in Japan. And it's hard to see that, but 4,000 miles is a lot of travel. That's like going from one end of the United States to the other is about 3,500 miles or whatnot. So you're talking about even further than that. Okay, going on here. Scientists have learned much about earthquakes and their effects. Oh, there's a play button on this one.
Scientists have learned much about earthquakes and their effects. They can measure even the slightest movements along faults. But we need to know much more about earthquakes before we can predict weeks or even days in advance when a big one will hit. Until then, proper building design can help lessen their effects. We now know that houses in earthquake-prone areas should be built on solid rock and not on sand, for example. In California and Japan, new houses are designed to be earthquake-resistant.
Resistant. That means that they're less prone to being destroyed by an earthquake. So it can resist, but that doesn't mean it couldn't. If the earthquake is so strong, there could be those that destroy. Okay, so not quite, but definitely stronger than the other ones. And they got it by building models, just like you did right here in class, and pulling out the earthquake hits. You guys were able to learn, hey, what stand, what made it fall, and what structures are needed. And that's what the earthquake kits were for, and we use them so we can see that and keep building new structures so they don't fall. Yep. And here is another picture. Let's zoom it on out. And if this house here is destroyed, you can actually see right here, there's a difference on what it was built on. It needs that solid rock foundation. And this one just here crumbled and probably wasn't built solidly enough. They even got a ladder going around the center of that. So I don't even know what that's for, but not built well at all as far as holding up to earthquakes. It also helps to know what to do when an earthquake strikes. If you're indoors, get under a heavier table or desk or bed. So, like when we have here and we have earthquake drills, we ask you guys to get under a desk because if anything falls, this desk here is somewhat solid. It's going to give you some protection versus not. Don't go next to a window, a mirror, or high cabinets. If you're in a high building, stay out of the elevators and stairways. If you're outdoors, move away from high buildings, walls, power poles, or any other tall objects. If possible, move to an open area. Above all, remain calm and don't worry. The chances of you actually being hurt during an earthquake are very slight, especially if you're taking the right precautions during an earthquake and not just like, yay, I'm here, ceiling, here, go ahead, stand on the ceiling. And it falls on you. But if you take the proper precautions, you do what you need to do, and you try to stay safe, then for the most part, you should be all right. The ground is not always going to crack under you. The faults and stuff have to be there for that kind of stuff to happen. Anyways, you guys are on part 6. It's the final, just answering a little questions about scientists and things that they would do. Back here in the back on page 33, there's a glossary in the index. If you ever wonder, like if you were like, man, what is energy? The capability of an object or thing to do the work. You need energy to everything you do. Energy provides food you eat. That's a different version of energy that would relate to you versus the one of in an earthquake. And you can always look here, like a tsunami, tremor, magnitude. And then if you're looking for something in particular, we use what we call the index. So if I wanted to read about the Marsali intensity scale, I know I'm going to go to page 23. If I want to read about a tsunami, I'm going to go to page 20 and 29 in my index. Very, very helpful when you're looking. Anyways, I will talk to you guys later. And all right, that's it for today. All right, bye. That's the end of our earthquake unit. Actually, no, we have a story, but this book we're done with. As we know it, it's the end.